Hey everyone, and welcome back. So today, we're diving deep into the tough and often totally invisible challenges that can plague a plastic injection molding operation. We're going to look at how a modern manufacturing execution system, or MES, can solve these sneaky problems that are secretly costing factories an absolute fortune, often without anyone even realizing it. So let's pull back the curtain and see what's really going on.
All right, so let me ask you this. What's the single biggest hidden problem in a molding shop? I mean, is it machine breakdowns, sky-high material costs, labor shortages? Now, sure, all those are huge deals, right? But the most significant issues, the real profit killers, well, they're the ones hiding in plain sight.
That's right, the biggest problem is what you can't see. I'm talking about those tiny little dips in cycle time. You know, the micro stoppages between shifts, or a process parameter that's slowly drifting out of spec. It's the kind of stuff that everyone just shrugs off as normal, or the way things are. But here's the thing, it all adds up to a massive loss in productivity. And most of the time, supervisors only find out about it after a whole batch of bad parts has already been made. And this number, wow, this really shows you the true scale of the problem. 60 to 65%. That's what you're looking at for a typical overall equipment effectiveness, or OEE, in an injection molding plant. That means a full one-third of your potential production capacity is just poof, gone, wasted. But on the flip side, it also means there's a huge untapped potential just waiting to be unlocked. So the question is, how do you do it? Well, to find the answer, we actually consulted a panel of leading AI models. And what's really fascinating is that they all came back with a crystal clear consensus. They all pointed to a foundational set of tools that every single modern molding plant needs just to stay competitive. And we're not talking about some futuristic sci-fi tech. This is the essential toolkit for right now. So the whole idea, right, is to make all that invisible stuff visible. And the experts agree, you start right here. First up, OEE tracking with detailed downtime codes, so you know exactly why a machine went down, not just that it did. Second, real-time monitoring of things like temperature and pressure to catch that process drift before it starts making bad parts. And third, tracking every single shot a mold makes. This lets you do predictive maintenance, stopping those catastrophic breakdowns before they happen. It's all about getting out of that constant fighter-fighting mode and moving into proactive, smart management. But look, it's not all about speed, right? It's also about quality and having real control. The experts all put a huge emphasis on these functions too. Think about full material traceability. If you're working with automotive or medical clients, this is totally non-negotiable. You've got to be able to answer that question, which resin lot was used on which machine with which mold, and do it instantly. A good MES also digitizes your work instructions and your checklists to slash the incredible amount of waste that happens during startups and changeovers. And hey, if you need a real-world example of just how much this costs, just look at this quote. A Monday morning scrap rate of 90%. Can you even imagine? Think about what that means. For the first few hours of the week, almost every single part coming off the line is garbage. This is exactly the kind of financial bleeding that a modern MES is built to stop. Period. Okay, so this is where things get really interesting. Because while all the experts agreed on those basics, it's where they started to disagree that tells us everything about where the industry is heading. Their debates highlight the strategic choices that separate the good factories from the truly great ones. Let's take energy management, for example. For ages, this was just, another cost on the spreadsheet, no big deal. But now the view is totally shifting, especially for any company that wants to export to Europe. With new rules coming in like Europe's Corporate Sustainability Reporting Directive, or CSRD, knowing your kilowatt hour per part isn't just a nice to have. For some businesses, it's becoming a ticket to play.
And it's not just energy either. The debates go on. What about tracking individual cavities in a mold? Is that just getting lost in the weeds, or is it actually a central problem that's messing up your entire OEE calculation? And should things like AI and machine vision just be a bolt-on you add later, or should they be built into the core of the system from day one? See, these aren't just tech questions. They define your factory's entire strategy for improvement.
All right, now let's get to the really cool stuff. Because beyond all the debates, a few of the AIs flag some truly unique, game-changing ideas. I'm talking about things from the absolute cutting edge that can completely flip the script on how a molding operation runs.
Okay, first up is a problem that happens all the time, but almost nobody talks about it: blocked cavity OEE distortion. So picture this. You've got a mold. It's supposed to make 8 parts with every cycle. But one cavity gets damaged. So what does the technician do? They just block it off, right?
The machine keeps chugging along at the same speed, but now it's only making 7 parts. A standard OEE system has no idea. It just sees the machine running, so your OEE numbers on the screen look fantastic. But in reality, you're actually down over 12% of your potential output. It's a total illusion. This chart just says it all, doesn't it? The dashboard is telling you everything's great, but the reality is you're leaking production. This is where a next-gen MES comes in. It's smart enough to know the state of every single cavity, so it dynamically recalculates the real OEE, giving you the truth. And like they say, you can't fix a problem you can't even see. Okay, here's another brilliant one, the drying interlock. So, you know how some plastics, like nylon or polycarbonate, are basically sponges? They just suck moisture right out of the air? If you try to mold them when they're damp, you get all sorts of ugly defects. Well, this system is like the ultimate safety check. The MES knows exactly how long that specific material needs to dry, and it will physically lock the machine, preventing it from using the material until it's perfectly dry. It's simple, it's brilliant, and it prevents one of the most common, costly defects before it can ever even happen.
And one last breakthrough idea for you. Almost every shop floor is a mix and match of machines, right? You've got an Arberg over here, an Engel over there, maybe a Kraus Maffei, and setting them up correctly often depends on who's working that day, or their tribal knowledge. Well, imagine an MES that stores the golden recipe, the absolute perfect settings for a job, and can just push it out directly to any machine on the floor, no matter the brand. It's about getting rid of human error and getting perfect consistency every single time. It's just incredible.
Okay, so we've covered a lot of ground, right? The must-haves, the big debates, and the real game changers. So what now? How do you actually do this? Let's boil this all down into a simple, actionable blueprint for building your own smart factory.
All right, here it is, your 5-step roadmap, and it's designed to be a journey, not a sprint. You kick things off with step 1, get that real-time OEE and downtime data. This is your foundation, and it's where you'll see the fastest payback. From there, you move to step 2, adding mold tracking and that super important cavity-aware OEE, so you're not fooling yourself with bad data. Next, step 3 is all about standardizing your process with digital recipes to lock in that quality. Then, in step 4, you go deeper with material traceability and those smart drying interlocks. And finally, step 5. This is where you really pull ahead of the competition, using edge AI and machine vision for automated real-time quality inspection. It's a really logical path, you know? You start with the quick wins and you build your way up to a full-blown smart factory.
So, let's wrap this up with one final thought. Look, the tech to fix all these hidden problems, it's here. It's real. And it's getting more accessible every single day. Your competitors, they're already using this stuff to get leaner, faster, and to win the jobs you're bidding on. So the real question you have to ask yourself is, are you ready to keep up? Thanks for joining me.